Good morning, ladies and gentlemen. Welcome to Illuminate Live. Well, it's not quite live because I'm recording this at 1:20 on Sunday morning, so I've got flexible working hours. And what I'm looking to do here is to give you a short demonstration. First of all, we'll have a look at a web page on the BBC website, and then I'll show you a short demonstration how I can share an application such as Excel, and then I'll give you a 2 or 3 minute maths lesson using the whiteboard. So we'll begin by looking at the web page. Technology in schools. Is the clock being turned back? Is the government's attitude to computer technology in schools taking us back to the dark age of chalk and talk? And this is an article talking about various government cuts in ICT in particular. Let's have a look down the bottom of the article where there's an interesting conclusion. Balance. Research from the US Department of Education concluded that students who took all or part of their class online performed better on average than those taking the same course through traditional face-to-face instruction. It also found that instruction combining online and face-to-face elements had a larger advantage relative to the purely face-to-face instruction than did purely online instruction. In short, a balanced use of both ICT and traditional learning achieves the best results. If the government does not believe its own agency, perhaps it will listen to evidence from abroad. Interesting times. Let's kill that off now and have a look at an Excel spreadsheet. This is one that I use for GCSE Foundation and Higher Tier, and because you're looking at a recording, I can't actually hand over control, but if this was students online, I could let them actually change the spreadsheet themselves. What I've got is an equation of the line y equals mx plus c, where m is the gradient and c is what we call the y-intercept, where it cuts the y-axis. And if we've got m is equal to 1 and c is equal to 0, it gives me a straight line passing through the origin, and a gradient of 1 means a slope of 45 degrees. If I increase the gradient, 1.1, 1.2 and so on, what we see is the line gets steeper. So a gradient of 2 is a lot steeper. If I come back down towards 0, we'll see that by the time I get to a gradient of 0, the line is horizontal. And if we go negative, the line slopes the other way. Let's get back to y equals 1x. What happens if I change the constant, the c? If I change it to plus 1, what happens is the line moves up the y-axis. It cuts the y-axis at a different point. And if I make c negative, it goes down below the origin. So that's a demonstration of using Excel, and as I said, I could allow students to press the buttons to see what happens for themselves. Right, let's get back to the drawing board. Right, a quick maths lesson now then. Let's have a look at a linear sequence. This is something that's on Foundation GCSE. Suppose I have a sequence 7, 10, 13, 16. Now typically here, we want to find the next 2 numbers in the sequence. Maybe we want to find the 10th number, the 25th number, or even the 100th number. So to start that, we need to discover what the rule is. Well, the rule here is we're adding 3 each time. So finding the next 2 terms is straightforward. 16 plus 3 is 19, and 19 plus 3 is 22. What if I want the 10th term in that sequence? Well, it's practical to keep going. I've got 6, so the 7th one will be 25, the 8th one will be 28, the 9th one will be 31, and the 10th one will be 34. So it's practical to go that far, but if you want the 25th or the 100th, there's really no point in using that method. What we need is a formula. So we're going to develop a formula for what we call the nth term, and n can be any number. So I might want n to be 25 for the 25th term, or n to be 100 for the 100th term. Well, if this sequence is going to go up in threes, what sequence do we know that does go up in threes? How about the 3 times table? If I write the 3 times table up here, 3, 6, 9, 12, 15, 18, and so on. Does that do the job? Not quite. But look at the difference between the 3 times table and the sequence we've got there. How do I get from 3 to 7? Or 6 to 10? We can see that in each case, all we need to do is add 4. So that means I can take as my nth term 3n, that gives me the 3 times table, 3 times 1, 3 times 2, 3 times 3, and so on, plus 4. And that will give me any term in the sequence. For instance, consider n is 6. When n is 6, 3 times 6 is 18. 18 plus 4 is 22. And that gives me the 6th term in the sequence. If I want the 25th term, then it would just be 3 multiplied by 25 plus 4. 3 times 25 is 75, add 4, 79. And we'll finish by finding the 100th term. That would just be 3 multiplied by 100 plus 4. 3 times 100 is 300, add 4, and we get 304. And that concludes the demonstration of what you can do live online.